Well, I was going to say is, I guess, as you can tell from the range of sponsors, so we've got Sloan, we've got EPA, we've got NIH, and we've got NASA, which are sponsors that have sort of what may seem like different missions and different needs, and that presents the committee with a really challenging but also a really interesting task. And so I think now is a great time for committee members to have the opportunity to talk to the sponsors and vice versa. About ways to approach this topic. I think that we heard a number of really interesting points associated with the research directions that are needed. I think Paula wanted to kind of know where the research is going in order to excite other folks in the field. I think David mentioned trying to perhaps enable some greater coordination among agencies. And so I think if there's a good opportunity to just have a discussion. Your statement of task, just to refresh your memory because it's a little bit long, is actually in the agenda books that all of the committee members have. For the guests who are participating as well, it's also in about the middle of your shorter packet. So we can all take a look at that. It's a quite extensive statement of task, and so I think it might be really helpful to have an interactive discussion about ways to break that down and ways to tackle those challenges so that we can try and meet the needs of 4 very different funding agencies. One thing that sometimes works is if folks want to maybe just stick their name card up when they want to talk, and then we can turn to you, Joan, to manage.
Or Ronald.
Yeah. Oh, I'm sorry. Go ahead.
Oh, Paula.
Who are you calling on, John?
I saw you first. I didn't mean to ignore Paula, so we'll go around first.
I just have a question for David. I'm just curious. Has there ever been, or have there ever been, episodic events in spacecraft where microbial infestation of any kind has occurred? And has that ever happened?
Yes.
Now, Counselor, would you like to elaborate on that?
I showed you a picture of one.
I must have missed it. The mold in the bathroom.
The mold in the bathroom, required that the panel be removed and replaced.
Yes, I did see that. I was just wondering if there were any other events of any note that...
There have not been any that caused an outbreak of disease or problems with humans. Yeah. But they're pretty carefully monitored.
Yeah.
The way, early on in the space program, the astronauts got respiratory infections, and they discovered back in the Apollo days that they had to quarantine them before they went.
Yeah.
They were bringing stuff along and passing it around. So they still undergo quarantine and isolation before flight to make sure that they're not harboring something new.
Yeah. What I was thinking about is that there must be a lot of outgassing of materials in the environment of a spacecraft. And I'm just wondering whether, if there were some episode or some known issue that you might consider dealing with, you might then tailor the materials that are incorporated into the fabric of a spacecraft so that it would outgas some material that would be preventative or useful in terms of controlling any such issue.
The engineers and builders are very concerned about off-gassing, outgassing, and that really is carefully controlled during construction phase. Part of the reason why everything is so expensive.
Yeah.
One area that you might think about, and I've challenged my colleagues in the physical sciences to think about the development of materials that would be antimicrobial.
That's what I was thinking about.
I don't think you would get. I don't think the people who take care of the astronauts would be very comfortable with materials giving off something to keep down the microbes. That would require a lot of study to make sure that it didn't impact health negatively. But if you had materials that were naturally microbicidal, or whatever the right word is, I think that would be a great contribution. And I think that would be good on Earth too.
Yes.
And look, it's not just the astronauts. I mean, there are pipes up there with water in them,
Sure.
and fluids in them, and guess what? They get biofilms that grow in them, and they get clogged up.
Yes.
So if you had the capability of building those pipes out of something that retarded the growth of biofilms, that would be something really useful, not just up there, but also down here.
Yeah, well, the same thought occurs to me when I get on an airliner, which is probably a great laboratory for all of the things we're talking about in terms of microbes and so on. But I just, well, thank you very much. That was very helpful.
Paula.
Thank you. I just wanted to make one remark that I think is very important in the context of the study, and that is the human microbiome is acquired during the first 3 years of life. Infants spend a lot of time indoors. The assumption is you get your human microbiome from your mother and your family, but we really don't know a lot about this. So the Sloan Foundation is funding some work, Jill Banfield and Bill Nazaroff out at Berkeley, to study premature babies in neonatal intensive care units, because it's a very simple environment in terms of the engineering, the microbes, and so on. But again, I strongly urge people to keep in mind that first 3 years of life, the human microbiome is being formed.
Did we see in that study that I think NIHS funds, that for cesarean-born babies, that in fact their first establishment of microbiome is in the hospital from the doctors and the nurse that they get exposed to, so they start to diverge from their maternal microbiome if they've had a C-section birth.
Right, but I think, did I break the rules?
Go ahead.
It's complicated.
I always break the rules. Yeah, it is complicated, and I don't think we've done enough long-term studies to see if there's an impact at all. I had two questions, David and Paula. One was about public engagement, and in the human microbiome space, there's been all this crazy press and people taking turkey basters and doing God knows what with them. So I was just one. Not you. It's not. This.
Turkey baster is golden.
Do not tweet that, Jack Gilbert, please. So my question is, in terms of public engagement, and I guess from Sloan's perspective, like, how has it gone with respect to the built environment? Is there as much excitement? It's probably not as sexy as the human microbiome, but it's just as important. That's one question. And the other point you brought up about trying to get all the groups to work together, we've had this in all the other fields forever. You know, the informatics groups, all these teams eventually need to come together so that the data is comparable. So I think that's something that we should try and address as part of this.
One of the points I tried to make in my talk is, and I was not clear, we did not spend money on public engagement. We spent money on MicrobeNet so that the scientists and engineers, so that that community would work together. So while we did not spend money on public engagement, the press has always been interested in this area. And so that was one of the points I tried to make. The other point is that it's very difficult to get people who, in order to succeed in academia, you have to be very focused, to get them to sort of move out of that space and work in a multidisciplinary space. And so a lot of the money that we spend in all of our scientific programs is this whole community building process, because lots of times other funders won't spend money on that. But we actually think it is good to go to dinner and talk about all sorts of things. We do assigned seating that. There's several good things about assigned seating. You mix up people based on universities, disciplines, and so on. But also that way, everybody always has a place at the table. So if you get to lunch late, you still have your good seat. You're not there like, oh gee, do I sit next to the full professor or whatever. So those are sort of two things that consciously. One is we didn't spend money engaging the public, but the public is very interested, and two, it's very important to sort of build community.
Thank you.
I'd like to respond to your question as well. Neither Paula nor I addressed it directly, although it's in my backup slides. Paula and I have been working together for the last year and a half, 2 years, to try to figure out something that Sloan and NASA could do together in this area. And we finally settled on the notion of funding some postdocs to analyze microbial isolates from the ISS. And it's taken us almost 2 years to get to the point where we now have a Space Act agreement between NASA and the Sloan Foundation. NASA has signed off on it. It's sitting on the president of Sloan's desk right now for signature. And we will subsequently have a solicitation offering a couple of postdocs that would be supported by NASA and a couple of postdocs that would be supported by Sloan. Why did I do this? I mean, I've learned a lot from Paula. I mean, and her community is not, it's overlapping, but it's not meshed with ours, and vice versa. There are some people who find their way, but we wanted to make a path for new investigators to be able to know that, hey, there's interesting stuff that's going on in a built environment. It's not just houses, spacecraft, or our investigators who focus on spacecraft, you know, hey, you know, maybe we have some tools and techniques and can, you know, do some cross-fertilization. So I think it's that kind of that kind of interaction. And this was, in fact, one of the things that was in President Obama's you know, instructions. The open data thing was for government and private foundations and commercial and whatever, you know, partnerships.
I think Vivian is next, and then Charles Haas, and then finally down to Tina.
Thank you. I have 2 questions to all 4 of the, or 5 of the speakers. I'm curious whether you can give us some references for any existing research on defining what is a healthy microbiological environment. So as a baseline, since clearly devoid of microbiomes would not be healthy, so we know that there's some mix. And as a corollary question of whether there are studies about in conditions in which the cure is worse than the disease, like flame retardants might be worse than fire risk, or antimicrobials might. So is there an existing body of studies that we should be reading? That's a question.
Unfortunately, no. There are a number of people in the room who were at the Sloan Foundation in 2009 when we brought together a group of experts to vet the white paper that I was writing for the roadmap for the microbiology of the built environment. And one of the goals we discussed at that time was, would we be able to define what is a healthy indoor microbiome? And the consensus of the group was it was just too early to do, and we could not do it.
Did you have another question, Vivian? You said, okay.
I have, well, a response. So I think one reason why we in Indoor Environments Division are concerned is it does look like there is some evidence to suggest that we are already altering the balance of the indoor environment by the way that we're operating, maintaining, constructing buildings, and that some of these pollutants that we're changing do impact health. And I believe that there is perhaps not a robust literature on that, but I have some articles in my backpack I could share with you. So I think I could provide you at least with a short list of some of the things that we were reading when we were thinking about why are we concerned about this. But I do agree there's no definition of what would be the ideal healthy environment, and it's scary in some ways because we're already doing, I feel like we're already doing an experiment and we're going to find out the answer. And I really hope that we're not pushing things the wrong direction by using mechanical ventilation that can, for example, perhaps dry out a building. So you're pushing, there's a different combination of organisms in there. Is that better than a building that's naturally ventilated? I don't know. I would like to know.
And the reason I'm here involved with this study is exactly for the second part of your question, because most definitely we know that the interventions that we've done, whether in ecological settings or indoor environments, to address one side of the problem have had unintended consequences. You use flame retardants as an example. Nifty nano antimicrobials are another area in which we're certainly seeing how easy it is to shift the balance and have unintended consequences. So that's why at least I'm.
And I wanted to chime in as a follow-on to this discussion. When we first started studying the built environment, we were studying homes, generally professors' homes and graduate students, and classrooms, because we're funding academic research, and these were the easiest places to get started in. And that was great. But, in terms of most professors are in very different socioeconomic groups than the average citizens. So we now are studying a number of other environments. We're studying a housing project in New York City. We're studying public housing in North Carolina. And if Kobe Shaw is one of the PIs in these studies, it's like if you look at if you just look at pictures of homes from the different studies, you'll see that there are just different challenges that people who live in public housing face that professors do not face. And so I think that there will be very different microbial environments based on insect infestations, poor maintenance problems. I mean, just lots of different things that are related to building operation and maintenance.
Just for future reference for the committee, Jack Spangler at the Harvard School of Public Health has done a lot of work in public housing, monitoring and measuring conditions. Might be a good expert for future.
Or the next generation, Gary Adamkowitz and various people who are trained by him.
Yeah, just a question for David Tomko. You mentioned biofouling. I'm wondering if there's any indication that biofouling conditions are different under weightless conditions versus on Earth. Has biofouling been an operational problem at all?
I can't really speak to the operational side. I would be surprised if it hasn't been at least a concern, if not a problem. We do have one investigator in the space biology portfolio, Cynthia Collins at RPI, who has looked at, and I'm going to block on the name of the microbe, has looked at biofilm formation, found that biofilms that are formed in space are very different from the architecture that they form on the ground. But that's really very preliminary. I think there's one publication on it. And we probably need to do more work.
Yeah, I have a question for the group, in that we've had a lot of emphasis on the health-related aspects and less on some of the biodeterioration structural components. Could any of you speak to where you think how much of our energy we should be putting on traditional issues like corrosion and wood rot?
All right, I'll speak. I think it's very important to remember that when the Sloan Foundation funds research, we do not have the answer. Okay, so I didn't tell you what I thought your answer should be, because I want you to come up with the answers. Now, getting specific to building deterioration versus health, I think it's a very important issue. The infrastructure in this country is crumbling. We have enough civil engineering civil engineers in the room who can give us what the grades are on various things. So I think it's a very important component.
So I'd just like to add, so from our point of view, I think it's important to consider things that cause structural damage. You don't want the building falling on someone. And also the deterioration of the building components as generating potential pollutants that are hazardous, and that's really the angle that we're interested in.
And just from my perspective and from a research approach, exactly because Paula said, I don't know which one of these factors are important, and I think they're all health related actually, right? I mean, we wouldn't be here if there wasn't impact to health, and that's where the energy and the sex appeal comes from, is if you can somehow demonstrate that it has an impact to health or negative impact anyway. So I think that from our perspective, all of those are contributing factors, and we would need guidance from this committee as to what are the most important of those factors we should focus on. And on that note, I think as the gut microbiome is attracting a lot of media attention, so is the built environment now. I'd say there's commensurate energy now in both areas. And we are, across the federal agencies, only the federal agencies being coordinated by the White House right now. There is an interagency work group that's being stood up as we speak. I just reviewed the membership of it. It's as diverse and as confusing as the funders are at this table. So we'll see where it goes. But at least now we know each other's names, which is progress. So,
Yeah, sure.
So I guess my question to EPA and developing standards for the microbial side, I know there's like questions about doing that on the human health side. So do you think that's going to be even remotely simple process? No.
the reason this topic is buried with Laura and me is because it's nowhere on the regulation side. We've got to set this up. We've got to cook it. We've got to, right?
Right.
It's not there yet, no.
And I guess the other point I was trying to make is that what concerns me is that some of the human microbiome press has created alarm in people because they think, no, we have a signature for colon cancer or
Right.
some
Oh,
kind
yeah.
of disease. And
That's-
I just wonder if you have that kind of concern or feedback from the community with some of the press that's out there.
What I hear more is how the chemical space is triggering those health effects, and the signatures are more correlated with the chemistries of the environments that people are living in. And I honestly don't know the answer. I mean, I see a lot of evidence. We see a lot of literature that has compelled us to make this investment intramurally and extramurally through this process. But I don't know what direction to go. I can't study all of it, so I need to know where to go and how to prioritize these issues or how to divide and conquer.
I'll just add that one concern that I hear from sort of the building science community is are we doing something in our operation of the buildings that's causing the generation of more pollutants or pushing evolution in one way, or are the products that we're using in cleaning and what have you indoors selecting for some resistant organisms or pushing things so that the balance indoors is off, that they hadn't even considered that we might be doing this before.
Okay, Jack. Sorry.
I just wanted to raise a point, and we were talking about interaction between the agencies and the need to focus not just upon the human health angle, but upon the fundamental science behind microbial physiology and evolution, which has obvious feedbacks into human health, but also can provide fundamental importance to determining what will happen to those bacteria when they land on Mars, for example, after you haven't cleaned the spacecraft properly. No offense. Or how we view biotransformation of pollutants in the indoor environment. Understanding the evolution and the physiology of these organisms is absolutely paramount to the future of this research area and is cross-disciplinary between the agencies.
Could not agree more. And I think there's a paper coming out of that working group that's describe the domain of interest, and I think you'll be satisfied that it's about as broad as possible. Because, NASA's at the table, NIH is at the table, EPA, NIST, USDA. And each one of these are huge microenvironments unto themselves. So yes, everyone's talking to each other, but how resources get distributed is a whole different question.
So there's a long a long history of NASA and the Navy and other entities that keep people in isolated circumstances and how to deal with the problems. I was thinking about that question that someone asked about biofouling, and I was thinking probably NASA's response to that would be to know which piece of equipment was going to be biofouled or wear out or whatever, and then just plan for replacement. And of course, that's okay when it's the same thing we do with our houses. When the pipes get clogged up, you just get a plumber, and if they can't be cleaned out, you replace them. I think one of the things that, in thinking about my recommendation that agencies work better together, is that if you could suggest any ways for even the four groups that are at this table to exchange information. I would ask the question of the folks at EPA, how do you tap into the reservoir of knowledge and expertise that NASA has built up over 50 years of building spacecraft with humans in them? Not that you're going to do that, but they may have had to solve problems which would give you hints about how to solve yours, and vice versa. I don't think we tap into this. And we do on the health side. We tap a little bit better with the NIH and exchanging and working together. But if there's some way that you folks can see in your deliberations over the next year, how to improve that, I think that might be helpful for everybody.
Yeah, I think that raises an interesting question that I'm looking around the table and seeing as a lack of expertise, is that we don't have a lot of social scientists here. And many of the questions that we're facing really have to do with economic, sociology, culture, behavior. And I would welcome hearing from our funders what they might have done along these lines already.
We've been funding basic science, and as I stated earlier, trying to develop a network and community of people who from different disciplines has been our focus. Mark Hernandez has run a series of community meetings at Boulder. The 5th one will be coming up this year. They've been very successful. But Mark has engaged some social scientists, so I don't know if Mark wants to talk about that early on, because again, trying to get the engineers to sit down with the biologists, to sit down with to get the engineers and architects to sit together. To get the people who are interested in evolution and the people who are developing databases. Again, people are so focused, and they have to be focused to be successful in academia to get them to move out of their space. So that's what
Okay. Laura?
Just in a recent workshop that the Academy held for us on indoor PM, we had a session on risk communication, and we deliberately had one at the end of the program. And I got a lot of positive feedback about how important that was and how interesting those sessions were. Not just what is the size of the problem and what do we worry about as scientists, but how do we explain this to people, and how do we put it in terms where they can take action, what is appropriate. So I do think that is important.
We wrestle with that as well, just in our own indoor studies, not even focusing on the microbiome, because that is an important attribute. But as Paula said, at this moment in time, we have much more fundamental understanding issues. And at least I feel that by people like Diane on the committee or Hal Levin, people who have done these studies in human environments, and if you get someone like Jack Spangler as to give a talk, I think you get some of that important social science aspects from their experiences of having done these field studies. I just worry that the committee might implode if you take on too many dimensions, but by all means, we get criticized for not considering the social science implications.
Well taken. Thank you.
Just in partial response to David Tomko, and the Navy's approach to biofouling is clearly not to replace the part. It's to get a bunch of swabbies down there and scrape off the biofouling. And that's a social sciences issue, because actually some of the important stuff I'm going to talk about just a little later is that our response to biocorrosion was the same thing. Get a bunch of swabbies to scrape off the part and put a whole bunch of caustic cleaners in there. And then they suddenly have chemical exposure issues, and we're inventing new cleaners. And so this starts to spiral and touch all sorts of different areas.
Thank you. Jordan? Or?
But just to follow up on that comment, I mean, from the point of view of biofouling, you also do use copper-containing coatings and paints, right, which have a toxic characteristic relative to some of the biofouling elements that are of interest. I mean, it goes back to my comment earlier about trying to tailor in space outgassing of chemical species at some reasonable dose that would not be harmful to the astronauts but would control a problem. And I think copper paints are a good example in biofouling.
I mean, if you're worried about the copper, forget that. We've got the chromate in the primers.
No, I'm not talking about chromate.
Well, right, but I mean, you know, we've stepped it up, and we're having to step it back.
Yeah.
Because we've gone so toxic.
Yeah.
And you know, and then there's the whole point of when you recoat, when you reprime the exposure during the maintenance effort.
Sure.
So I take your point exactly, but we don't do just the engineering part. We also do the behavioral maintenance part.
Gotcha. Thanks.
I wanted to ask Laura Kolb, you listed some questions at the end of your talk. I thought they were great. Is there a way the committee could get a copy of those?
Absolutely.
If they don't already have one. And then the second one is sort of implicit in your comments. I think I heard you speak a little bit about mold in homes and maybe the mold remediation industry. And if you did, or even if you didn't, I'm just wondering if any of the sponsors think that it's important for this committee to think about guidelines and guidance for the mold remediation industry that will likely, hopefully, benefit from this science and will use some of these techniques whether we want them to or not.
Well, I do believe that mold remediation guidance is really important. There are not just industry guidance, there are federal agencies that have guidance. There are professional organizations that have guidance that in many cases are comparable. And if this committee can make any recommendations to improve these across the board, not just for EPA or for people who are working as professional remediators, I think that would really be a plus.
I do want to acknowledge on our statement of task, the last bullet that highlights social, ethical, and public engagement, and the comments around engaging social scientists to help us communicate on 3 different levels. One is with each other, and the Sloan Foundation has put a tremendous investment in helping the different communities come together, building scientists, the biology community, the engineering community, to learn each other's language, to cross-fertilize and publish in each other's journals, either together or in special issues dedicated to this. And I think we have enough momentum in that community, some of which are sitting here, to be able to talk to each other without a social science as a facilitator, although in the beginning, we actually hired a facilitator to help us learn how to sit next to each other, to resist the temptation to sit with the same community that we do. So I think we're beyond that. I do want to recognize, and I think Hal's presence on the committee speaks to leadership that can cross that boundary, particularly with discussing with the public or discussing with professional societies or engaging the different communities to help forward this effort. So I think we have a lot of those elements here. I also have to say on prior committees, particularly with biosafety, biocontainment, risk assessment, we did have a person on each committee that was literally dedicated to the public side of this. And perhaps Jack could fit in that role, but we don't have that here. And the agencies have, by your charter, you have to talk to the public, and perhaps we should consider a specialist in that arena for public engagement. But I think at least the first two elements, talking to each other and crossing over into the professional societies, I think we're going to be okay. But it has been an investment and a ride and an effort, and it takes momentum to do that, and we'll have to pay attention to that, and we will.
Jean, you've been waiting.
So this comes out of the fact that I work in occupational health, and we do a lot of studies that's not in the built indoor environment. But I'd like to sort of ask the sponsors and speak to the rest of the committee about what is the range of indoor environments that we should consider. Mostly when we do our work, we're talking about homes, schools, but we were talking about the Navy now. So, for instance, we've had a lot of studies in metalworking exposures and the role of microbials and health there, and agricultural settings, food production settings. So, this could get incredibly wide. So I'm sort of almost asking, what should we stop at?
So for indoor air concerns, our focus is on homes, schools, and office or commercial buildings, not on things that are within OSHA's purview. And we really put an emphasis on residential scenarios and disproportionately impacted populations. And that's where, at least in terms of what we're asking for, we would like to most see the effort go.
I vociferously second that.
Can I challenge just for a minute, as a person who spends a lot of time in work environments, the homes usually are in the purview of the person who owns the home, and so repair ends up being a decision that people often make. Office environments, I've seen far too many basement work environments to know that we're letting, we may actually have worse microbiome situations in the work environment than we do, except in impoverished homes. And I'm just wondering if you're not suggesting we shouldn't focus on offices, but I just want to be sure that we don't overweigh. I know we spend more hours at home, but we spend a lot of those in sleeping. So maybe you could talk to that.
I can. Well, Vivian, we do want it all. But we do want offices and commercial buildings, but we want to focus on really helping the people who need it the most. So obviously, lots of times in commercial buildings, you have a system in place to take care of that environment, and we approach it in a different way. But people who are in their homes, that's really the bulk of where we're concerned that our disproportionately impacted folks would be.
And again, the bias in my research program is on those early life exposures. So that's the reason homes and schools are critical in terms of when the human microbiome is established. But by all means, we want it all. And if you can do it all, please do.
And most of our focus has been on homes, schools, offices. But, and I don't know if Jack stepped out of the room, but Jack was working in homes and was also collaborating with people at hospitals, and they said, but hospitals, it's a far more controlled environment. And so some of the studies that Jack has done, hospitals are great places to study, assuming they will let you study them. Now just getting access to study someone's home, office, building, that's like a whole, that's lots of building owners do not want their buildings studied for whatever reason. But One of the reasons that we were happy to fund the hospital microbiome study is that they really could make so many measurements, and that it was a new building, and you had lots of, they had 10 rooms on 2 floors, and the rooms were built identically, so it was just made better for the statistics.
Joe, I hadn't seen you had your card up. Apologies.
Yeah, so I have 2 questions. One question is that you see is the agencies have deal with like a long-term stability, because I thought you see this built environment, the dynamics could be very quick. So could be change daily, change weekly, monthly. So I know there's no foundation is 10 years, like any, because I thought this long-term stability could be a big issue. So any like agencies that are committed like programs to long-term monitoring. Okay, so like the 5 years, 10 years, like even like beyond this part.
All right, it's sometimes a little dangerous when I'm talking about the grantees' work that I have not read a paper on recently. But there's some work that has come out of Bill Nazaroff's lab with a technique, I'm going to say called UV VAPS, but basically if you use a laser-based technique to look at particles and figure out which the bioparticles are. So they can look at least particles that are going up and down in real time. But right now, using the culture-independent methods, we can't do that in real time. The next program that the Sloan Foundation is supporting is called Chemistry of the Indoor Environments, because when you start talking about what are the microbes doing chemically, you start really thinking about what's going on chemically. So if you had a marker that if something that the microbes are making, you can use analytical chemistry tools in real time to make measurements.
I'm not sure if I understood. I mean, certainly the longitudinal aspects are very important, but whether you're talking longitudinal over a 10-year time span, I don't think we can answer that right now. I think we'd appreciate guidance from you on.
Yeah, actually, you like NSF, DOE, to look at the nature system. They have long-term monitoring, like 5 years, 10 years. Because I thought all these programs found only for 2 years, 3 years, right? So the stability could be a big issue around there, because the dynamics change so quick. Maybe not so matters change, so like compensation, stability could be a big issue. Is there any intention from the even long-time program to monitor how to change, how to stability?
I think honestly, we have no program. I mean, I'll just speak about EPA. We don't have a program. We would like to develop a program. So the guidance from this committee is not to solve it, but to help prioritize, given the research scenarios and the resource scenarios, what are the most important areas in which the different agencies at the table should make research investments to begin to answer these questions. And we're not all going to end up doing the same things. We're going to take that report and incorporate what makes sense within our purviews. So we welcome those recommendations to know what are the most important, most relevant knowledge gaps that we need to invest in.
Yeah, we're coming up against lunch. Jonathan has had his card up, and so one more, and then we're going to break.
So my question, I think, is for everybody, but kind of sparked by maybe the work that David Tomko's group is doing with Gene Lab. And I guess my question is, where this fits in the bullets, I'm not exactly sure, but in terms of thinking about how do you control who has access to the data, particularly from a respect to privacy concerns and controlled access data, are those things that you're thinking about with Gene Lab or other groups are thinking about, so that, what are the challenges in terms of who gets to sort of analyze the data in a protected way that allows, opportunities for more data to be sort of looked at?
Well, the way I look at Gene Lab is it's one way of an agency or a program responding to the president's executive order that the data that underlie studies be made public, that the people, the taxpayers who are paying for it, get to see it, and if they want to analyze it. So ours will be public. Now, that is, we haven't, as an agency, I don't think we've wrestled to the ground how to deal with the human subjects. This is, it's pretty easy with the non-human biological specimens. If there's a principal investigator, once the investigator is finished with his or her analysis, that the raw data become public, and we're funding that. We're taking care of that on the backside of the experiments.
Many of the studies that Sloan funds do require IRB approval, and so and again, so each university or institution has their own mechanism for that approval. We also request that all of our grantees put their data in open databases, because ultimately you want to be able to look across studies to look at the bigger picture. And one of the challenges, though, for looking across studies right now is there, and I think Gary's going to talk about this later, is there's so many different techniques for doing these culture-independent methods, like which primer, which sequencing method, and so on. So it's not so easy, but it's very important to be able to share the data.
Okay, I think that is probably a great point. We have lunch ready. We should have enough food for everybody. It's right outside the room, and that includes actually our guests. I think we should have sufficient lunch for everybody who has braved the rain to come and join us for the meeting today. Let's take about an hour's break. We're going to reconvene at 1:30. And we will then hear some more presentations, and we can have further discussion. And we'll also this afternoon make sure we give a chance to folks who are not sitting in the table, but who are also here in the room to share some thoughts. So grab some lunch.